guys, starting here now, okay? Prove the following inequalities. P and Q are positive numbers because it says they're positive, okay? Now we have P squared plus 1 over P squared greater than equal to 2. Okay? What we're going to do is we're going to get a common denominator of P squared, both sides. If I put P squared on the bottom, I need to put P squared on the top. If I put another P squared on the bottom, I need to put another P squared on the top. What's going to happen is P squared multiplied by P squared is P to the power 4 plus 1 all over P squared greater than or equal to 2P squared over P squared. Now what happens here is all the P squareds cancel because they're all over the same denominator, and we can be guaranteed that the denominator is positive. The denominator is guaranteed to be positive. We can cancel off both sides. Now that that's done, we're going to bring the 2P squared over the other side, and what we're now going to have is P to the power 4 minus 2P squared plus 1. Now you guys have seen a quadratic like this before. It's what we call a substitution question, okay? And in the substitution question, what I'm going to let x be equal to P squared, and I'm going to explain why I'm doing that now. It's going to be, I'm going to break that up into P squared to be squared 2 times P squared plus 1 greater than or equal to 0. I'm going to replace, anywhere I see P squared, I'm going to replace it with x, okay? So just make this a bit taller, right? So I'm going to get x squared minus 2x plus 1. When I reference number that, I'm going to get x minus 1 squared greater than or equal to 0. Now, the whole point is it's not a question about x, it's a question about p. So let's change it back. Replace x with p squared, and you're going to get p squared minus 1, 2b squared, greater than or equal to 0. This is a perfect square, therefore it's greater than 0. Guys, thing to remember is if you ever end up with p4, p2 and a number, just remember this substitution, okay? Alright guys, so that's the answer to part 1, okay? And we'll just reduce it and put up here. Okay, so you can obviously copy that while we're doing part 2, because that's all part 1. Now we're going to be going on to part 2, which is next. So that's the answer to part 1. Now we're on to answer part 2, okay? Part 2 is P plus Q divided by Q divided by P greater than or equal to 2. Now the common denominator is to multiply the two denominators by each other, which is going to be QP, right? So if I put a Q here, I have to put a Q on top. If I put a P on the bottom, I have to put a P on the top. And if I want for there to be QP on the bottom, that means I have to put QP on the top to balance it all out. What happens next is we're going to get P by P, P squared, Q by Q, Q squared, all over QP, greater than or equal to 2QP over QP. Now what we're guaranteed about Q multiplied by P is what? Q multiplied by P is guaranteed to be positive. If it's guaranteed to be positive, we can cross them off both sides. Next thing, bring the 2QP over to the other sides. Now, some people were asking about a reference number method for doing these, and I do have a way. Okay? So I'll do a new reference number method for doing this. Okay? Now, if I can take it back to the easiest reference number you would have done, okay? And the easiest reference number you might have done would be something like this: x squared minus 2x plus 1. We'd say the reference number is 1 multiplied by 1. Would everybody agree with that? Okay, so the reference number would be 1, and then you'd break up 1 into whatever you need to get to minus 2. So it's technically minus 1 by minus 1. We all know that method, don't we? But what we're actually forgetting about is that, see the minus 1 and the minus 1, that actually represents what? They actually represent x values, don't they? So technically speaking, another way of looking at the reference number would be like this. It's just a slight modification on the easy reference number we know and have used very effectively, okay? Slight modification would be this. It would be not to use 1 by 1, but to use 1x squared multiplied by 1. What's 1x squared multiplied by 1? Basically 1x squared. And then we break up 1x squared into its two factors, which would be minus 1x by minus 1x. And that's how you get the middle part of the reference number. And for these letters, it's actually no different, and I'm going to explain now, okay? So, and remember, we multiply whatever is in the first part, underlined in black, by whatever is in the blue part, underlined by blue. Let's do the same technique here. P squared multiply by q squared. Everybody happy with that? That's your reference, yeah? Now what do you have to make in the middle? You have to make minus 2qp. So if I broke this up into minus qp minus qp, do both of them multiply together to give you p squared, q squared? They do, don't they? Yeah. So then what you could do is you could just do it if you're really not getting how to do these, you can just do them like this, and then factorize, and you're going to get p into p minus q into p minus q, and then what we're going to get, p minus q by p minus q squared, greater than or equal to 0. Adds on a bit of work, but if you really want to do it that way, who wants me to continue breaking them down like that for the next couple of questions? Okay, I'll do it, okay, just to say that it's done, okay? So it turns out to be p minus q squared greater than or equal to 0. So you actually can see it actually can be done. Okay? I just actually never bothered doing it before because I never had to. Okay?
So the first part I do 3 lines and then cross multiply.
You could do, yeah. It's actually the same thing. Yeah. 3 lines cross multiply is perfect. Yes, Simon?
Do you have a video on the list of the perfect square numbers?
5, okay. Number 3 or 5? 5.
3.
You can see they're actually the same question, except 5 is harder. So if you can do 5, you can do 3. That's the way it should work. Right, so let's do 5, okay? Now, 5 is done like this, okay? I have to multiply p by 1 over p. What do I get? P. P multiplied by 1 over 2q. What's that? Plus p over 2q. Next one. 2q multiplied by 1 over p is, anybody? 2q over p. 2q multiplied by 1 over q, or 1 over 2q. 2q over 2q, which is 1.
Would
Okay.
that not be then for p multiplied by 1 over p?
Oh yeah. Oh, I got it mixed up. Sorry, excuse me. It wasn't p multiplied by 1 over 2q. It was p multiplied by 1 over p. Yeah, you're right. P multiplied by 1 over p was the first one, and you're right. It is actually the number 1. Excuse me. Because p multiplied by 1 over p is p over p, which is 1. Okay, it's handy if you aren't good at them, just write them out in the corner and then rub them out a second later. It works much more effectively. Greater than or equal to 4. Now, what's going to happen here is we need to find the lowest common denominator. There is only 2 denominators, isn't there, Rory? It's 2q and p. What happens when you multiply them together? 2q p, or 2pq. Now, before I begin, what I'm going to do is I'm going to rub out the number 1 here to the side, and I'm going to rub out this number 1, and I'm going to change it into a number 2. I'm going to bring that number 2 over the other side. It's going to turn into minus 2. When I do that, that 2 disappears, moves over the other side, and then 4 minus 2, 2. Okay, so now my job is much easier. Okay, you can do 3 lines followed by 2 lines if you want, or we can just do the other method. This time I'll do 3 lines followed by 2 lines, just to give you a mix up in methods and show you they're exactly the same. So what I'm going to do is going to cross multiply and multiply the 2 bottoms. So I'm going to get p squared plus 2q multiplied by 2q, 4q squared, and on the bottom 2pq greater than or equal to 2. Now I'm going to cross multiply. It's basically 2 over 1. Is 2pq guaranteed to be positive?
Yeah.
This means I'm allowed cross multiply. Just keep remembering that with inequalities. You're only allowed cross multiply if your denominator is guaranteed to be positive. Okay? So now we cross multiply, we get p squared plus 4q squared greater than equal to 4pq. It's a 144, but if you don't want to learn that off, this time we're just gonna break it up using our reference number method again. Okay? So we'll break it up using the reference number methods. Now,
How do you know?
what'd you say?
How do you know you can use reference number?
It's a quadratic equation. P squared followed by p followed by no p. In the same way, it's x squared followed by x followed by a number that has no x in it. That's how I know it's a quadratic equation.
You have to do with the q squared. You have to go first.
Yeah, you could do it both ways. Yeah, do you want me to? I'll do it both ways actually, just to prove that it's the same. Okay. What Hugo was asking me was, why am I thinking that the p is the focus of the reference number? Why can't it be the q? So look, Hugo, what we're going to do is we're going to break it up into the same thing, and we're going to do the reference number, and you're actually going to see it turns out to be the same thing, no matter what happens. Okay. So this one here. There we go. So there's our two identical ones. Okay, so let's start off with our reference number. This time for these ones, our reference number is all of the front multiplied by all of the back. What is our reference number? Can anybody tell me? 4
Q squared, p squared.
q squared p squared, and we want to break these up into two numbers that multiply to get that, but add together to give you this. It's going to be minus 2pq minus 2pq. Are you happy with that? Yeah. Now, all we gotta do is write down both of them. 4q minus 2pq minus 2pq plus p squared greater than equal to 0. What you'll always notice is, lads, the middle part always just breaks up in half. You always just half it. So you almost don't need to go through the first part of actually going about doing it. Now, what's going to happen next is we're going to factorize. So in the first one we're going to take out, anybody? I say that's q squared. 2q into q minus
2q. 2q minus 2q.
q minus 2p. Look at it. Q minus 2p. What's guaranteed about the second bracket?
Q minus 2p.
It should be there. Same. But let's see if it does come out the same, okay? If it comes out the same, I'm going to take out p. I'm going to take out minus p. And if I take out minus p, I'm going to get minus 2q. Oh, sorry, give me a second here.
2q. Yeah, minus 2 is 2q minus p.
2q
Inside of this
minus p. Now, this way has actually turned out to be a bit mixed up, hasn't it?
Yeah,
okay. Sorry, I'm going to go back, okay, because we're just drawing a quick blank here at the moment. Alright, let's go again. 2q into, what did you say it was? 2q, I got you now. Minus p, excuse me. Okay, the next one is going to be minus
1
p into 2q minus p. It's 2q minus p, 2q minus p, isn't it? Which is going to be 2q minus p squared greater than equal to 0. Now you go, if you took it the other way, we would, I'm just going to put it down here, we would have done p into p minus 2q, and then minus has to be the same by default. Minus what?
2q.
2q into p minus 2q. And all of a sudden, this time we get p minus 2q squared is greater than equal to? Are both of them greater than equal to 0? Can anybody explain to me why are they both the same? Now that's a really hard one to explain. Why are they both the same? So, get this, okay? Shh, lads. See this, would you agree that p minus 2q is this here? Yeah? And if I multiply any side by minus 1 twice, does that side change? Multiply 5 by minus 1, you get minus 5. Multiply by minus 1 again, you get plus 5. So what happens if I multiply this one by minus 1 and this one by minus 1? Overall, I'm just multiplying it by 1. See what happens. We get minus p plus 2q minus p plus 2q greater than equal to 0. I'm allowed to just rearrange this, am I? I can say minus p plus 2q squared greater than equal to 0. Are they the same thing?
Yeah.
So just because you went 2 different ways, you still proved it was a perfect square. And as you know now, it's actually the same thing. Just a makeover.
Can you just recognise that straight away as I do?
I can, but a lot of people would struggle. Okay?
If you see that that's a 144, can you just write down straight away 2p minus p?
Or p minus 2q. Yeah, you would be able to do that. Yeah. There's no marks for the working, so you just want to really get it out. Okay, number 19 first, is it?
19.
That was asked for part 1 as well, wasn't it?
No, part 1 I think was
Part 1.
Did anybody want part 1, despite what was just said there? I'll do part 1, it'll take me a second. Alright, square both sides. A plus b squared over 4 greater than equal to ab. Cross multiply up to 4, square out the left. A squared plus 2ab plus b squared greater than 4ab. Move to 4ab over the other side. It comes minus 4ab. A squared, 2ab minus 4ab minus 2ab plus b squared greater than equal to 0. We should know this one off by heart by now. A minus b squared greater than 0. It's a perfect square. It's greater than 0. How many people got 19 part 1 now? Hey, well done. It's good. Very good. Now, next section. Next part I mean. 19 part 2. Square root of AB. Once again, square both sides. Square root AB turns into AB. The top turns into 2AB multiplied by 2AB, which is 4a squared b squared. On the bottom, it's going to be a plus b 2b squared, which is a plus b multiplied by a plus b. And we all know by now that's going to be a squared plus 2ab plus b squared. Now, this is guaranteed to be positive, isn't it? Okay, so we're going to cross multiply that up. So we're going to get AB brackets a squared plus 2ab plus b squared greater than equal to 4a squared b squared. Let's multiply these out. AB is going to be a cubed by b plus 2a squared b squared, and that's going to be ab cubed. I'm going to bring this over the other side. Minus 4a squared b squared. Okay, still haven't figured this one out yet. I'm just hoping it'll all come together in the last second. It's usually what happens. Okay, a cubed by b. These two are the same. This one here and this one here, they're the same language, so to speak. Alright, they're the same variables. That's going to be minus. Okay. And then finally at the end it's going to be AB cubed. Now what we're going to do is we're going to take out AB. Take out AB out of everything. And what we'll be left with is a squared minus 2AB plus b squared greater than equal to 0. Now all of a sudden we have a very familiar looking part to the question. And it all breaks down to AB into a minus b squared greater than 0. This is guaranteed to be positive as a is bigger than 0 and b is bigger than 0, and this is guaranteed to be positive because it's a perfect square. Yes, Hugo?
Could you do the reference number?
The quick reference number that seems to work for all of these ones is this. Break the middle one in half. So what you're going to get is a squared minus ab plus b squared. Then factorize. A into a minus b has to repeat itself. Then it's going to be minus b into a minus b, and then you get a minus b, which is a minus b squared. So you actually see, you don't even need to go through the reference number part. Just split the middle in half, and it works perfectly every time. Okay? So we'll do that. We'll do something like that again. Okay, number 24 now, is it? 24? Okay. 24. Okay, this one here. Prove that for all real numbers, a squared plus b squared is greater than 2ab. Well, just move the 2ab over to the other side and we're going to get a squared minus 2ab b squared greater than equal to 0. Then just factorize like we did in the last question. We'll get a plus b squared greater than equal to 0. Product squared is greater than equal to 0, hence it's always positive. Okay, let a and b be non-zero real numbers. Non-zero real numbers. Okay, now non-zero real numbers means that a or b could be negative, technically speaking, but when we add them together they result in a positive. So in this question it's very different from other questions because what could happen is there's two examples. A could be a number like minus 3, b could be a number like 5, and minus 3 plus 5 is bigger than 2, or b could be minus 2 and a could be 4. The bottom line is when I add them both together it's definitely positive. Okay, so we have to be a bit wary this time about what we're doing. Okay, now that we've done that, what we're going to do is we're going to work the 3 line methods on both sides. So is everybody happy? 3 lines on both sides? Yeah? Okay, so let's do 3 lines on both sides. The left hand side is going to be b squared and a squared. Yeah? A squared multiplies by a to give you a cubed. B squared multiplied by b, b cubed. Greater than equal to b plus a all over ab. Okay. Now, okay. I can't guarantee. What I can't do is I can't guarantee that a multiplied with b is a positive number, right? I can't guarantee that's a positive number. I don't know if this one is positive or negative. This means I cannot cross multiply it. I cannot bring that one up there. I am guaranteed that this one here is... How am I guaranteed that this one's positive? Squared, isn't it? So what I'm going to do is I'm going to bring this one up here, because I'm allowed to do that. Okay? So once I do that, what I'm going to have next is I'm going to have a cubed, different colour pen, a cubed plus b cubed is greater than equal to b squared, a squared multiplied by, I'm going to change that to a plus b if that's okay. B plus a, same thing as a plus b, all over ab. Now I can cross them off because they're on the same side. Okay? I'm left with BA or AB multiplied by A plus B. Now remember, difference of 2 cubes, anybody? A plus B.
A squared.
A squared minus AB plus B squared greater than equal to A plus B. Oh sorry, I forgot a part there. Greater than equal to, this is B multiplied by A, isn't it? And B multiplied by A is the same thing as A multiplied by B. It doesn't make a difference, I just tend to like it in alphabetical order. Now, what's A plus B guaranteed to be, Simon? So therefore I'm allowed to cross off 2 positives. And now all of a sudden, when I bring over this AB over to the other side, once again, the very familiar finish of 2AB plus B squared greater than equal to 0. And then finally, a minus b squared greater than equal to 0. How many people got that one now? So Simon? Well done, Simon. Is that the last question for today? Okay.
When you're doing the